चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. टुडे वी हैव दिस लैब segment routing automatic traffic engineering with BGP coloring. Okay, so this is the topology we have. We have a two provider router P1 and P2, and these are the two core router P1, P2. And to reach from the P1 to P2 customer network, we have these are the paths. One this path in the downside, and one this is the path from P1 to P2, then P1. So these are the links, and these are the different paths we are available if you want to send a traffic from P1 customer network to P2 customer network. So I have already done the IGP protocol, which we are using IGP ISS as a routing protocol, and I have also enabled the segment routing configuration. And these are the prefix-sid we are using. Prefix is 16033 on the PE1, 16044 on the PE2, and 16011 and 16022 on with respect to P1 and P2. And these seed values are coming, we have used the loopback fourth octet as the index number, using the SRG block 16,000 to 17,000. So we can say for the P1 loopback 0 IP address is 33.33.33.33. So fourth octet is 33. So prefix it is becoming 16,033. Same way P1 loopback 0 IP address is 11.11.11, and for the P2 address is 22.22.22.22, and for the P2 we have a prefix is 16,044. So the loopback 0 IP address is 44.44.44.44. And I have also configured the VRF name value is configured on the P1 and P2. And in this blue VRF, I have configured the loopback address loopback 100. I have configured the P1. For that loopback, this is the address which is the part of VRF blue. And the P2, I have configured the two loopback. First loopback IP address is loopback 100 IP address is this triple two is part of VRF blue, and another loopback 200 I've created for this IP address is this, and is also part of VRF blue. So with this segment routing automatic T with BGP coloring, what we'll do, we will first on the P2, I have so we can say we have these are the requirement for this loopback 100, whose IP address is triple two dot triple two dot triple two dot triple two with the part of VRF blue. We want the traffic should be go like this way from P1 to P2, then P2 to this back-to-back link, P2 to P1, then this link. And for this loopback 200, whose IP address is 200 or 200 or 200 or 200 is part of VRF blue. We are not doing anything explicit path, anything we are not defining. So this will take the dynamic normal path, which is the IGP low metric path. It will go. So we will not do any special configuration for this below one loopback 200. Okay. So how we'll do that? On the PE2, what we'll do? We will define the extended community color community. We will assign the color number. So this prefix, and under the route policy in address memory VPN, as we are running a VPN v4 BGP neighborship between the P1 to P2 to exchange the customer routes. While we advertise this route 2221 from the P2 to P1, we will under the route policy we will attach that color community. Once this route receive on the PE1, so we will do the segment routing traffic engineering configuration. In the segment routing traffic engineering, we will define the explicit path. We will define the one path, like we will give the path name blue. That path will be from PE1 traffic should go to the P2, then P2 to P1, then PE2. So this will be the path. This one, this one, this one. For this above one triple two one loopback will be part of VRF blue. And for this lower loopback, we are not doing any configuration. This will take the normal IGP routes for the next whatever available. Earlier in the segment of traffic engineering labs, we have seen that whenever we have config explicit part in the policy, we will also doing the auto router configuration to install the next stop or destination tunnel destination route in the IGP table in the forwarding table. But in this segment routing config, while we do the config on the header on the PE1, so segment will only define the explicit path after we define the policy and candidate path preference. That's it. So BGP will automatically trigger once this route will come triple two. So that policy, that traffic union policy will automatically trigger, and the turn will automatically should come up. And whenever we try to send this traffic to this prefix for this prefix from this source to this prefix, so traffic path should be like this way. So let's jump to the configuration. First we'll do the normal verification. First we'll do the normal trace route on the P1 to P2 for both of the prefixes, for the customer prefix which are connected behind the PE2, and after that we'll do the segment routing configuration, TE configuration the P1. After that again verify how the path will look like. Let's jump to the configuration. So here we are on the P1 node, head end node. Let's verify the, let me show you the current configuration. So these are the IP address on the interfaces. Okay, this is the, okay, so these are, so this is the router ISS IGP ISS routing protocol using the IGP. This is the core process is defined for this. This is the net ID, and this is the command you put for the traffic and distribute link state database level 2. So what we'll do, this will share the IGP database with the segment routing traffic engine database, and we're using the matrix style wide, and here we are enabling the segment routing in the ISS process, and here we are defining the prefix-sid index that will calculate the node seed for this node, and we have configured the point to point as segment routing exported on a point to point links, not on the broadcast link. And here we are doing the BGP configurations. So in the BGP configuration, this is the neighbor address of the PE2. Our provider is 2 router. We are running VPN v4 address family, VPN v4 neighborship with this. And here I'm defining the VRF value for the customer, and I'm doing the redistribute connected. And we have only, let me show you the customer loopback also should be there. So here, so we are creating a, this is the loopback which we are calling in the customer VRF. So let's see what are the routes we are getting in the VRF blue. Show route VRF blue. Okay. So from the PE2, this is the IP address of the PE2 loopback 0, and these are the routes we are getting 200 and 2221. Let's check the route detail one by one. Show route VRF blue 2, here it is, and sorry 200, and now let's check for the 222 also. So this is the next stop which coming from the PE2 is coming IP for unicast default. Next stop in the default here. So let's check for the BGP also. In the BGP VPN v4 unicast RDM I have configured 1.1 on the both of the PE. Let's check this out. Okay, this is the route it's coming from. It's coming from this, and this is the receive label. We can say it's a VPN label, and this is the extended community RD. I also use the 1.1. This is the route destination value. Okay, and yes, and if we check for the triple two also, here we go for the triple two. This is the next stop. This is the VPN label we have, and these are the communities. VPN before unicast VRF is blue. Here's the RD. Let's quickly check the Ceph also for this. Sure, sure Ceph VRF blue IPv4. Let's check for the first triple two. Okay, so here we are. So these are the, it's showing the load balancing. So as from the P1, we have a two path. It's connected with the two node P2 and P1. It's doing the load balancing, and this is the label stack. It's important. Okay, this is the VPN label, inner label, and outermost label is the our segment of the node seed prefixes attaching. And similar way for the entry will be the for the 200, 200, 200, 200 slash 32, which is also same. Here we here. So let's do the trace route also. Trace route VRF. Let's do for this 200. Trace route VRF blue. Local address in this VRF is 111. The trace route we have done. Okay. This is how it's going, and let's go for the 222 also. Both passes almost. You can say it's taking the correct stuff. Okay. So let's jump to the configuration part. So in both the cases, it's taking 2 hops to reach PE2 behind network, customer networks. So the 222 also 2 hop, 1, 2, and for the 200 also 2 hop, 1, 2. So let's do the configuration for the segment routing traffic engineering now. Segment routing traffic engineering, and after that we have to define the segment list. Let's to this name. Let me define this VRF is blue and 100 color we use blue 100. I put the name here. You can define any name. Okay, after that let's define the index 10, and let's put the label mpls label. First I want to send the traffic to the P2. P2 seed is 16,000. Not seed prefix seed is 22. After that we want to go traffic to the P1. P1 seed is 16,011. Let's change the index to 20. And after that one traffic should goes to the PE2 44 loop back index 30. So this is the index value defined on the index number 10, 20 and 30. Let's go to the now policy. In the segment of traffic engineering, let's define the policy. Also mention the, let's see what name we can put here. So we can define same name we can use. Let's say same name we'll use blue. For this blue we are 100. After that we need to define the color endpoint. So here it is. It's saying the color, specify color for policy. Color. Then let's say 100 will define the PE2. Then we define the endpoint. Endpoint will be the IPv4 address. And here we'll put the PE2 loopback 0 address. This will be the BGP VPN v4 address. Next hop. Actually it is not required. Okay. Once you define the color endpoint, after that we need to in candidate path preference. We can preference. Let's put the 100. And after that we need to call our explicit segment. So explicit path segment list, and segment to be defined is blue 100. In above when we configure blue 100 stack and column. Let's do this. This is the configuration way we have defined the segment list. This is the path we want, and this is the policy I defined, and this is the color community should be attached. Once this color community should be will get in the route when we advertise. So this SR PE will be activated and this path will be activated. So segment routing traffic engineering policy. The panel is up now. This is the color we have defined 100. This is the color endpoint. This is the name is dynamic calculated. The binding seed is taking the dynamic. So this will be the prefix seed, and this is the binding seed. Let's check the forwarding also. Forwarding policy. So this is the label stack it will attach, and this is the outgoing interface. Let's do the show ISS neighbor. as we want to send traffic to the P2, this is outgoing interface, instead of sending to the P1, and this will be the outgoing label. Okay. If we do the show mpls forwarding, so which is that's RTE, this one is showing the pop, no ideas at this. And if we check the route, so route 4444444, so it's showing only via the two path to interface. There is no SRT routes in the routing table. There is no route with the next stop is the SRTA. That will only be activated once we get the prefix with the same community. So let's jump to the PE2. We'll define the extended community with color 100, which we have defined in the SR policy here, color 100. And after that, we'll attach it in the RPL when they route from the PE2 to PE1. So here we are on the PE2 router. So let me show you the show run. Route IFS. Same way like P1, we have an ISS process, we have a segment routing enabled, we have a prefix-sid index 40 volts configured here. This loopback for the octet basis, we have calculated the index number. These are the two loopback 100 and 200 we have defined with the part of VRF blue, which we have seen on the route on the PE1 in the VRF blue. We were getting the routes, and we're going to configure the color community for this prefix for this loopback 100 with the part of VRF blue. And let me show you the BGP configuration also. Route to BGP. This is the BGP we are running from the PE1 to PE2, and the address family VP and V4. This is the neighbor. This is the IP address of PE1. This is the VRF blue, and we are doing the distribute connected as we have configured the loopback 100. So let's nothing else. This is the only with respect to segment routing. I define the global block. That's it. Okay. So let's define first extended community. Extended community. Then MLD OQ type. This we can define a name. Let's define this name is blue. You get any name, but number should match defining it. Okay. So we have given the name to the blue. And after that, let's do here we can do 32-bit decimal number. Let's put the 100 number in the PE and set. This is show. Let me do that. Commit. With the route policy. Route policy name again we do in the blue. That is the destination in. We're going to define policy for the loopback 100 prefix only, not for the loopback 200. This is the IP address. /32. The brackets. It's syntax for the RPL. Destination in this, then set where we have a community. Extended community. Then color we have used blue. Else pass and if and policy. So this is the policy. If destination is this, we need to set the color our blue, which we have configured extended community. So all would be look like this. Show run extended community. Community set Okay. This is the thing we have configured. Here we have defined the color, number, and here we are matching it. We are setting it. If this is this, set this color. Okay, let's jump to the BGP configuration here now. And the BGP will set the policy in route direction while advising the route towards the PE1 in the VP and V4 address. Let's go to the neighbor statement here. Let's go to the address family. And here we want the route policy name blue in the out direction. Let me do the commit. And the commits, let's check the route now. So BGP, VP and V4, unicast, 1:1 for this 222, that's 42. So that. So this is the local route. This is a local label, local VP label. This P attaching. This route. Origin local is origin local routes. And here we are extended community. Let's should here. So BGP, VP and V4. Unicast advertised. Here it is. It's showing correct for the so VPN V4 advertised. It is like two prefix 200.200 advertised to. So this is the address of PE1. It advertises this neighbor, and here in this, if you see, we have not applied the RPL route policy for this. Here you can see extended community is only our route target. But in the below in the triple two, once you apply the policy, attribute after applying the policy was applied. So this is the color is attached. Color 100 is good attached. Okay. So let's jump to the PE1. We'll do the again verification. We'll do the again trace route. We'll see. So here we are on the PE1. Now we have done the confirm on the PE2. So let's see that out now. Earlier we were showing the physical interfaces. First, let's check the PGP table. Start from this. Okay. Now you can see this here. Saying this route coming from the P2 color staging. This is the binding SID 24003 staging. Okay, and these are the things. Same way, if you check for the 200, which is also coming from the P2, but we are not applying any policy for that. So it's simple. It's showing the seed label and this. Let's check for the step also for this one. Both the prefixes 200. It's showing the next hop. We this one interfaces. Now you should see here the E for this triple two. Sorry, in the three part that's fine, but before that I want to show you. Show success. Really run the command. Show success. Here it is. Here you can see it's in the next hop is SRTE, while for the normal it's showing the next hop is the interfaces. So So while we checking, we can check, okay, next up with the SRTE. So this will take me the SRTE path. This is the label embodiment VPN label and in place with null showing the list source segment routing traffic engineering forwarding policy. So this is the partitioning and this is the tonnage up and this is the explicit path we have defined and it's fine binding and all those stuff. Next to the trace route, earlier trace route with the two hop for both the prefixes. Now for the triple two, it's taking three hop. It's going to the P2, then P1, then PE2. And if you do the same trace route for the 200, the two hop, one hop, two hop, and here we have defined explicit on basis of color on the basis of color community in the path and taking the SRT. Thank you.